All right, let's work on page 2, bottom half, about odds and probabilities. Now, we've done a lot of probabilities, and we've always looked at what we want to happen, or what we're looking for is on top out of all the different other possibilities. Odds are extremely similar. We just need to know what we're looking for over, instead of a total, it's how many we're not looking for. And they refer to them as A and B. Okay? So for example, a probability of rolling a 2 or less on a 6-sided die. That's how you write that out. And on a 6-sided die, a 2 or less. So that's a 2 or a 1, which is 2 possibilities. Okay? A 2 or less is a set of 1, 2. Something's wrong with my pencil. Hang on. Gracious. All right. Set notation. A 2 or less is 1 or 2. So 2 choices out of 6 or 1/3. Okay. The top number is how many we're looking for, which is 2 or less. And the bottom number is how many is possible, and then reduced. The probability of drawing an ace. Well, there are 4 aces in a deck of 52 cards. Reduced is 1/13. Okay. How do we say this in odds? Well, the odds of rolling a 2 or less on a 6-sided die is what we're looking for, which is 2, a 1 or a 2, over what we're not looking for. So if there's a 6 total, what we're not looking for is 4 possibilities. So a 3, a 4, a 5, or a 6 would be not what we're looking for. Okay? So then that would reduce to 1/2, or 1 to 2, or just 1/2. Okay? That's the A, and that's the B. If we're drawing an ace, the odds of drawing an ace, well, the top number would be 4, right? And the bottom number would be whatever 52 minus that 4 was, which is 48. So this would be A over B. So it reduces to 1/12. Okay? So let's see, if we were to draw one card 13 times without replacement, we'd expect to get an ace once and not get an ace 12 times. That's what this is saying. Okay. Probability and odds are just stating the situation differently. When they talk about odds, they frequently talk about odds in favor and odds against. Okay. You have to keep that straight, because odds in favor is the A over B. Odds against is that reversed. Okay. Commonly in slang is the odds of, which is kind of weird to me, but okay. That's what it says in the book. So, for example, the odds of Cleveland repeating an NBA championship is listed as 5, odds of 5 to 2. The odd makers are predicting that if the season were played 7 times, Cleveland would win the championship twice and not win 5 times. So this is against, right? This is the slang for against. So 5 to 2 is against Cleveland. Okay. So for practice, we have our 6 colored balls in our container, 3 green, 2 blue, 1 red. What are the odds of pulling against, pulling out a blue ball on the first pick? So sometimes I think of odds for, which would be there's 2 balls, 6 altogether. So 2 balls I want, 4 balls I don't want. So odds against, or odds of, would be 4 over 2. We always want to reduce and then watch whatever form they want it in. 2 to 1. Oops. 2 to 1, or 2 over 1. Or you can use the literal word 2. Okay. What are the odds against pulling, odds of pulling out a red ball on the second pick if the first was blue? Let's see. Odds 4, there is only one, and if the second pick was blue, there's only 5 altogether. So therefore 4 balls. Remember, we picked out 1, so there's only 5 balls in the bucket. And if we're doing odds, remember, we don't want to write the 5 down. That would be a probability. We want all the number of balls that aren't what we want. So there's only 1 red 1 out of the 5 that's in there, so there are 4 that I don't want. And then that's the odds for. So against or of would be 4 to 1, like that. Okay. And then more odds on the next page. So we want a formula for converting from odds to probabilities and back. So odds to probabilities, all you do is take that A number, put it over both the A and B. Remember, that's the total, and you got your probability. Okay. The odds in favor is the probability over 1 minus the probability, and odds against. So that's a little more confusing. We'll look at an example. According to the National Safety Council, odds of dying due to an injury at some point in your life are about 10 to 237. So find the probability. Well, the odds, the top number is the A, the bottom number is the B. If it's written this way, you can think of it as 10 over 237, okay? A and B, so that A goes here, A plus B on the bottom is here. Then calculate out your decimal. 10 divided by 247 is about a 4% chance, okay? Here's another example. Probability of getting 1 pair in a 5-card poker hand is that. Odds in favor of getting exactly 1 pair and odds against. So odds in favor, you take that probability in favor, put the probability on top. 1 minus that probability gets you the probability against. I don't know if you need to, if you need the probability, you're here. If you want a decimal, you can divide these, but this needs to be turned into a decimal by multiplying it by 3 place values to get this number, 3 place values to get, excuse me, this value. So this doesn't reduce, by the way. So this is A and that's B. So you can write it like this or you can write it like that. Odds against, they're just flipped. Okay, so let's practice that. When 2 dice are rolled, the odds in favor, assume they're 6-sided dice unless they tell you otherwise, okay? So you roll 2 dice, the odds in favor of getting the sum of 9 are 1 to 8. Find the probability of not getting a sum of 1 to 8, a sum of 9. So this is 1 to 8. So clearly odds, okay? So A is 1, B is 8. Odds in favor, 1 goes on top, 1 plus 8 on the bottom gives you 1 over 9, which is your probability of the event happening that we're looking for. Okay, so remember, it can be fractional form, or you can put it in the calculator. Let's see, it depends what they're looking for. 1 divided by 9 is a repeating 1, so approximately 11% chance, which kind of means more than odds to me, but that's 4. So it said the probability of not getting, so that would be probability of not getting would be, if it's probability of 1 over 9 getting, so 8 over 9 not getting, or about 8 repeating, so around 89%. chance of not getting a sum of 9. So good chance. All right, odds in favor of matching 5 of 6 numbers on the classic lotto game are 1 and that. Find the probability of winning this lotto. Winning. So odds in favor. So A is 1, B is 54, 1 over 1 plus 54, 0 to 1 is 1 over 54, 0 to 2, which comes out to, when you put this in your calculator, you're going to get something that looks like this. It's going to say E negative 5, which means it's a really small number in scientific notation. So I think to myself, super small number, as in I need to move this decimal to the left 5 times, which means I'm going to be putting 4, remember we don't count this one, 4 zeros in front of this number. That's how 1, 2, 3, 4, 5. Move the decimals 5 places. That's what that means in your calculator. Okay. Does it say? It doesn't say what I'm rounding to. So this is well past. If I was rounding to 4 decimals, it's still 0% chance of winning this lottery. It's not 0, but it's really close to 0%. Okay, these are your, that's your probability of winning. Okay. All right. So there, I went through the homework. There are a few that you will end up with 0 when you round to what they request to. So try to remember, keep, to look this up when you get that. That does come out to a 0 for what they're asking for, because there's a 1 here. So that means we don't change the 0. So even though it's approximately 0%, that's what they're looking for. All right, 150 people were surveyed by phone for their favorite cola. The results are tabulated in the table. Find the odds and the probability of each response. So these are frequencies, okay? And that better add up to 100 for your sum. Sorry, for your sum of your frequencies is 150 people. So odds in favor. Odds in favor. Let's go with, okay. Sorry, trying to be fast here. Favor. All right. So what do I need for odds? I don't need the total. I need the total for probabilities. These are 150. This is 29 over 150. And when you put that in your calculator and round it to 4 decimal places, you get that. Okay. But for odds, I need 150 minus the 29 to give me the 121. And then in favor would be 29 over 121. Okay, so these I can run down really quick. If you leave them in fraction form, make sure they get reduced. Like that needs to be reduced. That one doesn't. This one does. Okay, so you can reduce them or take a moment and put them in your calculator and you don't have to worry about them being reduced. So it just depends what they're asking for. But all these will have to be subtracted from 150. This one's going to turn out to be 129, 113, 122, 131, 134. So 16 over 134 reduces to 8 over 67. So these do need to be reduced if it's necessary. So this is 28 over 122, which is the same as 14 over 61, 37 over 113. It can be 2 dots or a line or a fraction, right? 21 over 129 actually reduces to 7 over 43. To keep consistent, let's put the dots. Alex will tell you what they want. Okay. This comes out to 7 over 50 or 0.14, 0.2467, 0.1867, 0.1267, 0.067. And these should add up to approximately 1 when you get them all done, or 100%, right? Relative frequencies. When I add them all up, it actually comes to 1.0001, so close enough, okay? And in the homework, they're going to say a Pepsi product. So in these, you're going to be adding frequencies. So a Pepsi product, so you have 21 for Pepsi, Diet Pepsi, add them together, get a new frequency. 150 minus 49 is 101. So this would be 49 over 101 for the odds in favor. Okay. For the probability, it'd be 49 over 150. All right. So don't forget to add your different choices together on that one.